Hi students, welcome back. Today we're going to be looking at physics. What we're doing in physics today, we're doing scalar and vector quantities. Now you might wonder, what is a scalar quantity? What is a vector quantity? Now there's a difference between scalar quantity and a vector quantity. Do you know the difference? All right, let's see if you really know the difference. Now, for a scalar quantity, speed is an example of a scalar quantity, but why? Weight is an example of a vector quantity. A scalar quantity is basically a quantity that is fully described by a magnitude only. And what we really mean by magnitude, we mean size. So a scalar quantity has size only. It is described by just a single number. Some examples of scalar quantities include your speed, volume, mass, and time. So for short, scalar quantities are quantities that have only size. So there is no direction involved in a vector quantity. Now we have weight, which is a vector quantity. A vector quantity is basically a quantity that has both a magnitude and a direction. Vector quantities are important in the study of motion. Some examples of your vector quantities include your force, velocity, acceleration, and momentum. Can you think of any other scalar quantity or any other vector quantity? Think about them as we go along. All right? No, there are many differences between scalar quantities and vector quantities. We're now going to look at some of the basic differences that exist between scalar quantities and a vector quantity. Your scalar quantity has only magnitude, as we mentioned before, but no direction, while your vector quantity has both magnitude and direction. So in essence, if you want to remember the difference between a scalar and a vector quantity, a scalar quantity only has the size that you're measuring, but your vector quantity has something to do with your direction. Where are you going? For example, if we're playing a game of tug of war and somebody is pulling you and I am pulling back, no, that would entail direction. So whichever quantity is coming out in that, which we'll see later, then that definitely has to be a vector quantity because direction is not involved. All right? Now, every scalar quantity is one-dimensional, while vector quantity can be either one-dimensional, two-dimensional, or three-dimensional. Number three, any change in scalar quantity is a reflection of change in magnitude. So only size changes in your scalar quantities, while any change in your vector quantity can reflect either a change in the direction or change in magnitude or changes in both. So there are times when the number remains the same, but there is a change because the direction changes for vector quantities, that is. Now, scalar quantities cannot be resolved as it has exactly same value regardless of direction. So your scalar quantity cannot be resolved as it has exactly the same value regardless of the direction. Vector can be resolved in any direction using sine or your cosine of the adjacent angle, and we're going to be calculating some of those later. Now, any mathematical, that's number 5, any mathematical operation carried out among two or more scalar quantities will provide a scalar only. So whatever you do with two or more scalar quantities, you're gonna get a scalar quantity. However, if a scalar is operated with a vector, then the result will be a vector quantity. And for on the vector side, results of mathematical operations between two or more vectors may give either scalar or vector. Dot product of two vectors gives only scalar, while cross product or summation or subtraction results in a vector. Our CXC students, you don't have to worry about these technical terms, but CAPE students will definitely be doing some of these calculations, all right? Now, number 6, final one on this comparison table. Few examples of scalar quantity: length, mass, energy, density. Examples of your vector quantity: displacement, velocity, acceleration, force, etc. Please stay with me as there are some questions posted at the end of this video. So it's important that you watch to the end so that you're able to answer the questions that are going to be posted. Now, these are more examples of scalar and vector quantities. Now you're seeing some of them that are very popular scalars. So you have your length, your area, your volume, your speed, your mass, your density, your pressure, your temperature, energy, entropy, work, power, volume. These are all scalar quantities. While vector quantities, you have your displacement, your direction, your velocity, acceleration, momentum, force, lift, drag, thrust, weight. These are all vector quantities because they have something to do with your direction. On this slide, we have some more examples of scalar quantities and vector quantities. You realize that we have a lot of examples, which means that one of your questions will definitely, see, I'm giving you a clue, one of your questions will definitely ask you about scalar and vector quantities in terms of to give examples. So please know at least 5 of these examples: 5 scalar quantities, 5 vector quantities, sorry. So know these different examples of scalars and examples of vector quantities. All right, let's go. All right. All right. So we have some more here: scalar quantities: time, mass, speed, area, volume, work, power, pressure, charge, length. For your vector, we have displacement, your velocity, acceleration, force, weight, torque, momentum, electric field. All right. Now, examples of scalar and vector quantities. What I want you to do, as I asked earlier, I want you to go ahead and write down at least 5 examples of scalar quantities and 5 examples of vector quantities. So write those down in your notebook, students. Please go ahead and do that. So you can pause this video and write down the examples of scalar and vector quantities. Do not continue until you are finished. Pause here. All right, so now you're finished. You've written down examples of scalar and vector quantities. I want you to go ahead and type your examples. So you can type your examples in the chat, or you can type your examples in the group, or you can type in the comment section. So go ahead and type your examples of scalar and vector quantities so that your teacher can view them, all right? And let's see who gets them all correct. Now we're going to another subtopic: adding scalar quantities. Because scalar quantities only refer to quantities that have size only, we must add these quantities as numbers. So example here, we have 0.5 liters. And do you know which quantity do we measure by using liters? Can you tell me? All right, so if you said volume, that's very good. So we have 0.5 liters plus 0.5 liters plus 0.5 liters. If we want to find the total, we go ahead and add the numbers only. So we're going to add 0.5 plus 0.5 plus 0.5. And what do we get? Yes, we get 1.5 liters. So we are adding scalar quantities. So to add your scalar quantities, you just add the numbers and you keep the unit. That's how we add scalar quantities. If we were to subtract, we would definitely do the same thing. Now, your scalar quantities can either be added, subtracted, multiplied, and divided like ordinary numbers. Let's say, we're on the work site. 3 kilograms of sand is added to 1 kilogram of cement. So we're mixing something now. Resulting mixture has a mass of, what's the resulting mixture? If you should mix 3 kilograms of sand and 1 kilogram of cement. Very good. The answer is going to be 4 kilograms for the mixture. Now, if we have 5 liters of water being poured from a pail that has 8 liters of water in it, what's the resulting volume? So you have 5 liters and you take that away from a pan that had 8 liters initially. What's the final? Very good. So we're going to go ahead and say 8 liters minus 5 liters is equal to 3 liters. So no direction is involved in adding your scalar quantities. Now for your vector quantities, that has everything to do with direction. So an arrow is used to represent the magnitude and direction of a vector quantity. So the same direction is equal to some opposite direction minus. So if we're both going in the same direction, both vector quantities going in the same direction, you add. And if they're going in opposite direction, we have to subtract. An arrow is typically used to represent the magnitude and direction of a vector quantity. Example, velocity of the airplane, 100 kilometers per hour, but you have to show the direction. So the wind velocity is equal to 20 kilometers per hour. The direction is very important because that's what we measure when we're looking at your vector quantities. So if we're going in the same direction now, the resulting velocity of airplane is 100 plus 20 equal 120 kilometers per hour. What we mean by this is if you have the airplane going at a velocity of 100 kilometers per hour and there is wind going at a velocity of 20 kilometers per hour and the wind is blowing in the same direction that the airplane is going, then the speed or the total velocity, the total velocity is going to be equal to 100 kilometers per hour plus the 20 kilometers per hour, which is gonna be 120 kilometers per hour. And we're dealing with velocity, which is a vector quantity. Now, if we're going in opposite direction, so the airplane is going in one way and the wind is blowing in the opposite direction. What it means is that we have to subtract because different direction, we subtract. So the resulting velocity of the airplane is going to be 100 minus the 20, which is equal to 80 kilometers per hour, which technically, if you have the wind blowing in opposite direction, it slows it down. But if the wind is blowing in the same direction, then we're adding some more velocity there. All right? Now we're at the activity section, part 2. I want you to go ahead and name 3 examples of vector quantities in addition to the ones that you did. Name 3 examples of scalar quantities. And tell me, what do vector and scalar quantities have in common? What do they have in common? And how are they different? So pause the video right here and go ahead and complete this section of scalar versus vector quantities. All right? Pause the video there. When you're finished, you're gonna hit play. The next part, we have some scalar quantities and vector quantities here. I want you to identify, so draw a table, put scalar as one heading, vector as one heading, and put all these quantities that we have under the correct heading. So I want you to put all the scalar quantities under scalar section and put all the vector quantities under the vector section. If you get everything correct, then there's going to be a prize. All right, so I see you, you're doing well. I see you, you're doing so well. Keep going. All right, yes, yes. Okay, Good job, students. Good job, good job. All right. Great job, Tajina. Great job, Brianna. And great job, Jessica. You all did very well. Now, let me see what you have done so far. Send in your work. Now we're actually at the end of this video. So thank you so much for watching. I hope that you would have learned about scalar and vector quantities. Remember to like, remember to share with somebody else who you know is studying physics and need this assistance. And if you want to see more content relating to physics, chemistry, biology, mathematics, or any other CXC subject for that matter, please hit the subscribe button so that you can get alerts for when we post new videos. My name is Felisa Ricketts, and it was nice being here with you. Have a wonderful day, everyone. Thank you.